Thank you. Good morning. My name is Omar Malik. I teach at the Heidelberg School of Business in Heidelberg University, which is in Tiffin, Ohio. It's a small liberal arts college. Most of my teaching is in business, so I teach strategy, international business, management-related courses. But say for the last 4 years or so, I became interested in data science, and I started learning about data science and learned R and Python and all the tools that are in there and some of the conceptual approaches. And over time, my research started moving in this direction too. So my research now has started sort of finding this intersection or sort of defining this intersection between social science theory and the use of big data and machine learning. And this is what has come out of that research. So basically what this paper or this presentation talks about is how these things, like big data and machine learning, can actually be used to develop social science theory. And why is this new? It's new because we don't develop social science theory like that. So social science theory for a long period of time has been developed by thinking of ideas which stem from ideas which were rooted in old social science theories. So it's a deductive process. And I am suggesting that we can do something slightly different. And this slightly different is new to the social sciences, but it's not new to other sciences. So say, for example, if you look at genomics, it has done a lot of pattern-based type of theory development. So that's what I'm going to talk about. I'm going to talk about the importance of theory. Why is theory so important to social sciences? What are the reasons why we should use big data and machine learning? And then I'll try to point out what are the attributes, at a conceptual level of this type of big data that can actually be used for social science theory development. And what are some of the methods in which we can apply this to theory development? Also, I'll talk about machine learning, and I'll talk about what types of machine learning can contribute in what ways to social science theory development. So since it's a small enough group, maybe we can go and quickly introduce ourselves and tell me a little bit about what your interest in this topic is, so that then I can sort of move around and customize things in a way that they speak to what you are interested in terms of this topic. If there is an interest in this type of social science theory development. But so maybe we can sort of quickly say who we are and what our interest in this area is. And then we can take it from there. You want to start?
Yeah. I'm an econ grad student looking to use big data in my thesis and career.
Jim Carson, I'm the data science manager at Service Express. We do data center hardware maintenance. So I'm very much in the business world and not in the academic world. So I come here to get exposure to these type of things because it's not what I do on a daily basis.
I'm Mariel. Once again, I'm a data scientist at Spectrum Health, and I'm interested in social science aspects because I'm trying to expand some of our data science and our modeling that we do around patients to focus a little bit more on some of their social interactions and their and the expectations that we might see given their social spheres and their populations, as opposed to specifically disease-specific things.
My name is Jason Benjamin. I'm a manufacturing engineering manager at Gentex Corporation in automotive industry. I'm here just to get exposure to different topics and to learn whatever I can.
I'm a systems analyst for Challenge Manufacturing, also an automotive manufacturer. Kind of same deal, just kind of seeing what else is out there and what we can utilize.
My name is Bang Lee. I'm a graduate student at Western Michigan University. I'm interested in big data, and I hope that I can learn something from this talk.
What are you a graduate student in? What area?
Excuse me?
What area are you a graduate student in?
I'm a PhD student in statistics.
Statistics.
Okay, so my name is Chong. I'm a graduate student in statistics, and I'm interested in machine learning. So I just try to see what areas can those machine learning apply to.
Hi, I'm Patrick. I'm also a master's student in statistics. My undergrad was in agribusiness management, so I guess this talk would kind of like try to look at what the relation could be between those two topics.
Elizabeth Oliver. I'm also a grad student in statistics. Just mostly interested in expanding my understanding of how machine learning is used in application.
Hi, my name is Omar Malik. I'm also a grad student at WMU. My major is statistics. Just when I see always I hear big data and machine learning, I see how it's really would apply even in different disciplines. Or what kind of data, when you collect data, what kind of thing you look into it, and what kind of supervised data you use, or what kind of statistical method or thing that you're using in your research.
Hi, I'm Omar. I'm from WMU University in the statistics department. I'm interested in big data.
My name is Adam Rand. I'm with Amway. I'm an analyst on the supply chain side. So once again, just business practicality, understanding big data, understanding the concepts of machine learning and how we can apply that back to the business.
I'm Amanda Jenkins. I'm a R&D scientist at Ergo, and I'm a master's student in data analytics as well. Interested in seeing what just like.
Thank you. All right, so let's start. So what is theory? I'll start with the most basic question. What is theory and why is it important? Theory in the social sciences and in other sciences is the explanation part in the social sciences. And it's supposed to do two things. It's supposed to explain phenomena, and it's supposed to predict phenomena. So say, for example, if you have an international trade theory, it's supposed to predict the patterns of trade. Why do America and China trade? Why do America and Russia trade? So it's supposed to explain those patterns. There has to be an explanation component, which is the why of theory. And then there has to be a predictive component that, given certain data about, say, the trade relationship between the United States and Russia, we should be able to predict that pattern of trade. And so that's what theory does. So theory is central to the social science enterprise. Why? Because it provides the base knowledge, which constitutes social sciences. And in any science, theory is relatively important because that is what constitutes the accepted knowledge of that area. And good theories are practical. Why? Because they can provide good explanations, and then they can also provide predictive power. So you can use this theory to predict what could potentially happen. So in that sense, the idea that things which are theoretical are not practical is not true. A lot of practice is really based upon theory. So in that sense, good theory is important. So what are the components of theory? Theory focuses on, so if you were to break down theory into its parts, what are these parts? The first question is what? What is this theory about? So, and one, the phenomenon. So we are trying to explain a certain thing. So we are trying to explain why firms in a certain industry sort of have competitive advantage. So what drives competitive advantage in a certain industry? And that's the what part. It's the broad phenomenon. Also, the what part includes what specific concepts explain that. So it could be that firms have resources, or firms have certain types of capabilities. Those capabilities meet certain criteria, and consequently, those concepts become the what. The second question is, how are those concepts related? So the how is the second component of theory. So what is the phenomenon? What are the different concepts in that phenomenon? And then how are they related? So what is the nature of the relationship between them? Is it a linear relationship? So if you have more of a certain type of capability, you have a bigger competitive advantage. So it's a straight linear relationship. Or is it a U-shaped relationship? Or is it an inverted U? So it basically comes down to the specification of the function, between two different concepts. So that's the how part of theory. Then the third part is the most important, which is the why. The why is the causal logic of the theory, which is saying, yes, these two things are related in this way, but this is why they are related. So which is explaining the logic of why they're related. So yes, capabilities lead to competitive advantage under these conditions because these capabilities allow firms to create new products, which are products which are demanded by customers. They can also be priced higher. Consequently, the firm has competitive advantage. So that is the why part. And in all these components, the why is the most important contribution to theory. Why? Because it is the logic. It is the logic that holds the theory together. And then there is the when, who, and where, which specifies the boundaries of the theory. So a theory has to have a limited domain. So say some theories might apply to emerging economies. So we can say that, say for example, firm learning theories apply in a certain way to certain emerging economies. So we could say these theories apply to actors, firms who are actors in emerging economies, where in these emerging economies, when, during a period of liberalization. So all theories have to have these sort of boundaries associated with them. Why? Because you can't really have a general theory, because it can't apply to all situations in all people or all objects at all points in time. So there has to be some sort of circumscribing of that theory, and these are also called the boundary conditions. So the when, who, and where are also labeled as the boundary conditions of a theory, because they sort of circumscribe what the theory is trying to explain. So these are the components of a theory. So every time somebody presents a theory, it has to have these components. A theoretical argument has to have these components. It has to have a what, which explains the phenomenon. It has to have a how. It has to have a causal logic, which is the why. And then it has to have certain boundary conditions which kind of delimit what this theory is all about. Then within theories, you can have theories at different levels of development. On the one hand, you can have nascent theories. So they are brand new. We are just starting to look at this phenomenon and trying to understand what is going on here, which is nascent theory development. So in this case, we don't have very fixed ideas about what is going on. We're trying to understand them. So say, for example, crowdfunding as an organizational phenomenon. It's a new thing, relatively new from an academic standpoint. So ideas about it, theories about it, what works, what doesn't work, what kind of organizational outcomes it leads to, whether it affects a firm's innovative performance or not, are all ideas which are tentative at this point in time. So that type of theory development is called nascent. As ideas become more developed, what you have is intermediate level of theory, where you have some ideas which are logically sound. You've identified some constructs. There are possible explanations, but there might be multiple explanations for the same phenomenon. Say, for example, there's a relationship between corporate social responsibility and corporate performance. And there is a debate in the literature about whether corporate social performance is responsibilities leads to performance, or does performance lead to that? So are firms which are more profitable become more responsible from a social standpoint, or does social responsibility lead to more performance? So there's both these explanations. There's causality in this direction and causality in that direction. And so researchers are trying to tease out, they're trying to identify other variables, they're trying to identify variables that mediate that relationship, moderate that relationship, try to look at data over a time period, try to develop causal models to try to sort of figure out what is going on here. So there are some ideas. Yes, corporate social responsibility is important. Yes, these are the types of things. They have to be environmentally responsible, they have to be socially responsible. So there's all these ideas. But how these ideas link to each other, what the causal logic is still somewhat up in the air. So that's an intermediate level of theory development. And then finally what you have is mature theory, which is logically sound, has been tested multiple times, and is accepted as knowledge in that domain, but knowledge tentative to being disapproved. So all theories are accepted to the point where we don't find data that actually disapproves the theory large scale. So a little bit of disapproval of the theory doesn't kind of displace the theory. The theory has to be displaced by a lot of evidence suggesting that this doesn't work. So what you have is you have theories which are well established. So say, for example, in strategic management, there is a theory that says firms that have unique resources and capabilities that customers value and also create value for firms lead to potential competitive advantage. Very strong. Lots and lots of evidence supporting this. So lots of ways of testing it, lots of meta-analyses that prove that this is something that holds. And it holds in different types of firms in slightly different ways, but those boundary conditions have been tested in multiple scenarios. So that type of theory is mature theory. So I think we've talked about what theory is, and I've given you some examples. And so it's important to understand this idea because that's what we are trying to do. theory development is the central enterprise. That is what social scientists do. And this research kind of addresses a different model of developing, that theory. So how was theory developed in the social sciences historically? What has been done to develop social sciences theory? One, we have old theories. So as you go through a PhD program, you learn all the theories of your area. So you take seminars in different types of theories, and you absorb these theories. So your cognitive maps actually become reflections of the ideas of the theorists of the past. So what you have done is you absorbed all these theories. As you absorb all these theories, what you do is, as you start working towards your own research, you deduce logic from these existing theories. Now, let me point out 3 different ways of actually developing new knowledge. And actually, these are the only 3 ways in which you can develop new knowledge. The first way is deduction. Deduction is that you have a set of principles, and you deduce new principles from them. So you've got an existing theory, and you say, well, this theory says broadly this theory says this. However, in this case, based on these arguments, this is what it's going to do. So it uses deductive logic. The second method is inductive logic. Inductive logic is where you take examples. So you say Patagonia behaves in this fashion. We can learn this from Patagonia. However, Nike behaves in this fashion. So what you do is you develop knowledge case by case, and then you try to put it together to develop a higher level scheme of what firms do. That type of knowledge is called inductive knowledge. The third type of knowledge is that you look at patterns of things. So you look at pattern of unemployment, and you try to come up with a plausible explanation for it. Now that type of knowledge is somewhat tentative, because it's not deeply rooted in either evidence, which is the inductive case, where you have a case where you're actually developing knowledge based on that case, or it is also not rooted strongly in logic. And that third method of developing this tentative knowledge is called abductive thinking. So you've got these 3 types of logic. You've got deductive logic, inductive logic, and then abductive logic. So in most cases, new theoretical propositions that are published in journals are deduced from existing theory. And then in cases where you have nascent theory development, it relies on inductive theory development. And the approach is called grounded theory development. So what you do is you go and find cases. And then you find these cases, you develop knowledge about them. And say, for example, if I wanted to find out what small Midwestern manufacturers are able to be competitive in the face of Chinese competition. And I want to come up with a theory that says, well, small Midwestern manufacturers really don't stand a chance against Chinese competition because Chinese firms are large scale and they have low cost of production. But there are cases of firms which are tremendously successful. What types of firms are these? What is a theory that explains which of these firms will actually do well in global markets? That type of theory development would require me to identify specific manufacturers in the Midwest, go interview them, find qualitative data on them, then eventually find some quantitative data. And that process is known as nascent theory development or grounded theory development. And then traditionally, once we have a theory, so we deduce the theory or we develop it in an inductive fashion if it's nascent theory, and then we go and collect data. And we test that theory using a sample or data that we have collected. So that's the traditional model in which theory development and testing has happened in the social sciences. And this is for a very long period of time. For social sciences have worked in this fashion, that there is theory development, there is propositions from the theory, then there's hypotheses from the theory, and then we go and collect data and test the theory. So data comes at the very last stage. It is basically used for testing theory, except in the case of nascent theory development, where qualitative data actually serves as the base for developing the cases. Now, why does it make sense to use data? So if data is only coming in at the last stage, it really is a question that why don't we use it in earlier stages? Why don't we sort of look at the data to drive this? Especially because we have so much data available. So Facebook is creating data, Twitter is creating data, large data sets are being put out by the government. Private corporations, non-profits are collecting data. So there is all this repurposable data which is available, which we can use as part of this abductive thinking. So we can look at this data, we can identify patterns, and then we can say, well, these patterns suggest that it is possible that this is what is going on. And then we can develop theoretical sort of propositions. So we can actually use from this big data, we can use these large data sets to identify patterns and then to come up with concepts, to jump back and then come up with propositions and hypotheses. So what is different about this is that it's saying instead of using data at the very end of the research process, where you actually just use it for testing, you are actually using data all through the process. And the reason you're doing it is because you have so much of it available. And it will, and as I'll point out, it makes the process a bit more effective. Second, you could also use automation in this process. Why? Because one way of identifying patterns is by humans identifying patterns, but we can only look at so much data. Machines, on the other hand, can look at very large amounts of data. They can sift through thousands of variables. In that sense, we can identify patterns using machines. So the concept of using machine learning becomes important when you start realizing that you can actually make this process much more efficient. You can go through large amounts of data, identify variables which might potentially be important using this machine learning. How does this help, this social science theory development enterprise? One, traditionally, the link between theory and empirics is the measurement part, the data part. Theory is the conceptual part. In research, which was published in one of the top journals in management, they actually looked at the correlation between theory and empirics. Within business management research, that correlation is 0.15, which is very low. So what you have is that you have a theory, and then you have a way of testing it, and the correlation between what the theory is saying, what the tenets are, and what you are actually testing is 0.15. It's ridiculously low. Now, if your theory development was based on data, obviously this will go up. So there is clear link between using data at the earlier part and then measuring things and trying to sort of understand them at an empirical level, which would improve as a consequence of employing data. Second, there have been 3 stages of developing theory in the social sciences. There is the exploratory stage, where you actually go and develop cases or ideas about what's going on. That's the nascent theory development. Then there is the explanatory stage, which is basically the intermediate theory development, where you actually try to link these concepts together, define functions that link them together, come up with the causal logic, which is the why aspect. And then there is the testing phase. I have a theory, I will go and collect data and test it. Now, all 3 are separate. So people who do explanatory research don't do too much testing research. People who do testing research, pure empirical research, don't look at conceptual aspects. So what you have is, within the social sciences, you have very clear divisions of people who do theory work, people who do case-based work or grounded theory development, or people who do pure testing, who just look at ideas that other people have developed. And their entire careers are based on that. However, it would make sense that if you wanted to develop better knowledge, that you would want to integrate all these things. That you would want all 3 stages to be integrated somehow. And this offers the potential to integrate them in some fashion. And third, I had talked about the functions of theory in the beginning, and I said good theories do 2 things. They explain and then they predict. So as you work on your dissertation research has to do 2 things. It has to explain a phenomenon, and it has to predict that phenomenon. Now, in the social sciences, we have a lot of explanations. But the predictive power of our models is very, very low. So I can explain why certain firms I can completely explain why Amazon is so successful. But can I predict who's going to disrupt Amazon? I can't. So I can come up with a complete explanation for why Apple has competitive advantage, in a certain industry. But can I predict what new technologies will shape that industry? I cannot. So what we have is, we don't have predictive power associated with our models. And so we are only doing half the job. We are not doing the other part of the job. And over time, this model of social science theory development has focused on this explanation part. So this has become the traditionally accepted part of theory development, is just explain. Nobody is asking for prediction anymore. But this prediction is an important component. So if you go back into the philosophy of science and you look at people like Karl Popper, he's suggesting, he's pressing for prediction. He's saying, well, a theory is only useful practically from a standpoint. And notice that, say for example, theories about business and management are not used in businesses. That's one of the reasons why academics are sort of, not people who advise these organizations, primarily because the theories that they have are not applicable to the types of businesses. They explain the past, but they don't explain the future, whereas most business decision making has to focus on the future. So it creates relevance. If we can come up with a way of creating theories that do explanation, but also provide some degree of predictive power, suddenly the social science enterprise will become more relevant to real life. Suddenly we will have more real life organizations paying attention to what we do. So those are the reasons why this is important. And let's talk now a little bit about, I think this helps in terms of people who are interested in big data. What is this big data? What is different about data? We've had data for eons. I mean, we've been, the whole sort of quantification revolution started in the 1820s, and objects sort of got numbers associated with them, and we started collecting data. Governments got involved in collecting data. But what is different about big data? Or is it just a term, with a lot of loaded concepts into it? And I'll start with an industry-based explanation. And this was, something that I think somebody associated with IBM came up with. And they say that, well, big data has 4, attributes associated with it. One, it has volume. It's a lot of data. So in most cases, it is, either terabyte or petabyte size data. So this is a lot. It's data that can't be held on one machine. It is data which is, very large just in terms of its volume. And so if you look at, say, for example, Facebook data or Google searches, I mean, these are very large, or say data streaming in from a number of sensors in a company. So it's a very large data set. So it's what happening is that you are collecting very large volume of data. Second, it has variety. It is not just one type of data. So traditionally what you had was numbers-based data which is organized in relational databases. So what you had was tables of data. This is not just tables. This is voice data. This is video. This is text. So this is all types of sound files. This is all kinds of data. So what you have is a variety of data. It is not, and it could be structured. It could be completely unstructured. It could just be text files. It could be PDFs. I mean, it's any form of data. So that's the second attribute of big data, is that very large and in many types of forms. The third attribute is that it's coming in at a very fast rate. It doesn't stop. It's not something which is, you have a data set that you collected data and now you're sort of stagnant. It's happening in real time. It continues to flow. It has this flow associated with it. So say, for example, if you look at a Twitter stream, it's coming in, it's flowing. And that makes it difficult to analyze. Why? Because any models that you're developing, there's a new stream of data coming in. And so then the model has to hold for this one. And so if you look at, say, for example, Wall Street data, it's coming in at millisecond speed. So there's a lot of data coming in very, very fast. And it has to be analyzed and decisions have to be made. So that characterizes a different form of data. You don't have, in many cases, you may not even have time to develop models. Your model is just trying to adapt on the fly. Then the fourth aspect, which is not so positive, is the limited veracity of this data. In many cases, it is incomplete. In many cases, people have put in the wrong names. In many cases, things are missing in it. In many cases, it doesn't represent what you want to look at. So the veracity or the reliability of this data, the quality of this data is highly suspect. And in many cases, you have to impute things into it. You have to assume that these are the values that go in, which from a scientific perspective makes it somewhat problematic. Because to develop good knowledge, you need very accurate data. You need data which is actually valid, which captures what you want to look at, and which is reliable. If you measured it again, it would be the same type of data. Now, people who have looked at these attributes of big data in academia, so the first four, the 4 V's of data that I mentioned are coming from industry. But then within academia, people have looked at whether actually big data has these attributes or not. What makes big data different? And what they've argued, and there's a paper by Kitchen and McCardle, which kind of argues that not all big data have volume or variety. So say, for example, if you were looking at getting some data from Twitter, it may not be that large, and it's all text-based data. Or if you're looking at administrative data from, say, a college admissions database, it may be all quantitative data, and it may be organized in tables. So it doesn't have to be that it has volume or variety. But what makes it different is the two attributes are that, one, it captures all of the population. So say, for example, if I'm interested in a certain type of phenomenon, it captures all of that phenomenon. So Facebook captures all Facebook users. So in that sense, it's exhaustive. It captures the entire, n is equal to all, which is different from n is equal to 250 or n is equal to 25,000 or n is equal to 50,000. This is n is equal to all. So whatever you're looking at, whether it's representative or not, you've got the whole thing there. So that's one attribute of big data. And the second is this velocity aspect, that it's flowing in. From a theory development standpoint, it's real-time data. So if you're looking at a protest and you're trying to develop a theory on who participates in protests and you're looking at Twitter data, you're actually getting that data in real time. So that's one important aspect, that it allows very relevant theory development, because you're looking at the real thing. So if you're looking at corporate social responsibility and you're looking at data that is coming in from corporations that are actually undertaking actions and they're filling up a survey or they're putting this data out there, it's real-time data. It's not old. It's not. And from a social science theory development, let me tell you why this is so interesting. It's interesting because in most cases, by the time a social science paper gets published on average, that data is 2 to 3 years old. So the entire process is so long of developing research and writing it up and whatnot and getting it through the journals that the data becomes fairly old. So in that sense, any time lag that can be reduced will increase the relevance of those ideas. Second, it's unobtrusive. So the data that is being picked up, the people who are providing that data are not able to react to that circumstance. So they can't really change because they don't know what that data is being used for. So it is being repurposed. They're just putting it out there, and then somebody else is picking it up. So, and that helps them not modify their behavior because they're being looked at. So unobtrusive data can lead to better findings because you have less reaction to that data. It could, on the other hand, be incomplete. You will not get all the people that you're interested in. You might be getting a sample which is non-representative, which is again a problem. And then people move in and out. So some people may be there in your sample. Later on, they may not be there in your sample. They may have modified their behaviors for other reasons. The algorithm might have changed. So the way, say, Twitter feeds were being carried out, or the way Facebook was collecting data will change based upon their commercial interests. And their commercial interests dictate changes to the algorithm, which dictate changes to the type of data and the way in which that data is being collected. So all three of the last ones make it somewhat problematic for theory development. Why? Because it's incomplete, it's non-representative, and it's changing over time based on those three dimensions. So what I did was that I actually looked at how big data can actually be used for developing theory. So since theory development is so important, and we've talked about what big data are, how can we actually use this? And I developed two dimensions. My first dimension is the type of theory development. And I pointed out what nascent theory development is. This is developing brand new theory. So we are looking at a brand new area of developing theory. And then I also pointed out what intermediate theory is. Here we have multiple explanations. We've got a lot of concepts. But we're not really sure how they relate to each other. Which ones of these theories is actually a better theory? So we might have multiple explanations. And I gave the example of the corporate social responsibility literature, where you have this relationship between corporate social responsibility leading to performance. So firms that are responsible have higher performance, or firms that have high performance become corporate, socially responsible. They want to be socially responsible because they have a reputation to protect. So that type of area is intermediate. Now in mature theory development, big data really doesn't have that much of a role, because it's somewhat tentative. And I pointed out attributes of this data like incomplete, non-representative, drift associated with it, which when you have mature knowledge, when you are sure about your claims, you may not need that type of data anymore, because it's not really going to help you develop tentative ideas. So that's the two sort of cells. And then on the other side is data integrity, which is critical to theory development. In a theory development environment, you have to have data that has two attributes. It has to be valid. It's actually measuring what you seek to measure. And second, it has to be reliable. And what I mean by reliable is that every time you go and measure the same thing, it has to be the same way. It has to be the same type of data. So you can't have that sort of movement, that wiggle in terms of data collection. Now, so you could have two types of big data. You could have high integrity data, or you could have low integrity data. And so think of theory development as these two stages, nascent or intermediate. And then think of data integrity as being either data which is complete, representative, doesn't have much drift, or data that is on the other extreme, has lots of missing values, is completely non-representative, and then it has quite a bit of drift from people, behaviors, and algorithms. And then I sort of define the implications of big data on this type of theory development along these four cells. And I'll talk more about them. So the first cell is high integrity data. So we've got valid, reliable data, and we are looking at developing brand new theory. This is the most promising aspect of big data. So what we can do here is we have the ability to illuminate what is going on from an empirical standpoint. We can actually generate patterns from this data, and then we can try to understand it. And let me give you a real example of a data set that actually can do this. There's an organization called B Labs. What B Labs does is that it collects data on what are called B corporations. B corporations, the B stands for benefit. B corporations are corporations which are socially, environmentally responsible in a way that they have made it a part of their mission statement. So legally, they are supposed to be firms. They have a role, the board of directors has a role to ensure not just profitability, but also social, environmental responsibility. B Labs provides the certification for being a B Corp. They, over the years, starting from 2012 up to now, they have certified about 2,500 firms. So 2,500 firms are B Lab certified B Corps. They have extensive data on every single management, governance, environmental, social aspect of all 2,500 firms, starting from 2012 right up to now. And this data continues to flow in. The rate of growth in these firms over the years, so how many companies have become B Lab certified, on average year on year is 49%. So it's a growing trend in the United States. There's lots of firms becoming B Lab certified. Now this data is complete, it is valid, it is reliable, there are no missing values in it. All of these organizations certify their data, and B Labs has opened this data to research. It's open. Anybody can access it. So this is very good data for developing theories about the phenomenon of how firms become socially and environmentally responsible. What happens to their performance? It can be linked up with external data sets. So many of these firms are publicly listed. We can go to organizations like outside organizations that sell databases and link up this data. So you can get performance information on them. You can get financials on them. And once you link up this data, you have a very rich data set for developing theories of corporate social responsibility, or ideas about why certain types of firms become responsible. So that's the cell of high integrity and nascent theory, most promising. Why? Because as I mentioned in the B Labs case, there is clearly an avenue. And the B Labs is just one example. There's another database called SharkWatch, which looks at activist investors. And there is no theory in strategy about what the role of these activist investors is in terms of management of firms. Again, you have a very reliable data set. You can develop theory, you can identify patterns, come up with propositions and hypotheses that explain this phenomenon, and then use a subsection of the same data set to actually test your ideas. And so that's what the benefits of high integrity data are in nascent theory development. In terms of intermediate theory development, you can supplement things. So say, for example, if you have a basic theory, you have some ideas about what would work or what would not work from a theory development standpoint. What you do is that you use this high integrity data to test those relationships further. Furthermore, the relationships can be tested using cross-validation. So machine learning has an approach which basically what it does is that it breaks a data set into multiple pieces. And then you can use some pieces to develop the theory, and you can use other pieces to test the theory. That way, what you do is that you have an independent test of whether these ideas hold or not. And so cross-validation can be very useful in terms of intermediate theory development, because what you have is you have some tentative ideas about what potentially works. And you might be able to develop new ideas about which relationships hold using folds of that or pieces of that data set. Now let's talk about the two cells that come from low integrity data. And this is the more problematic aspect of theory development. Like I pointed out, theory is basically knowledge. And you can't really develop knowledge if you have data that doesn't really measure what you seek to measure, or is not reliable over a period of time. So the first question is, can these problems be addressed? Can we actually fix the problems in the data? Maybe we can find external data sources. Maybe we can use imputation. Maybe there is a possibility that we can select a subsample from that data. So all of those are ways in which you can sort of control for the problems in the data. And you can address some of these sources of bias and sort of make this data useful. And then you can go back to theory development because now you have somewhat higher integrity data. Even if you don't address these things, even if your data has a lot of holes in it. Say, for example, if you're looking at a Twitter feed of a protest and you're trying to come up with a theory of a protest. Now you have incomplete data, it's non-representative. In many cases, people may not be saying what they mean, or what they actually think, so it's invalid data. Can you develop tentative ideas? Yes, you can. Why? Because these are ideas that can then be tested with more rigorous data. You can actually go out and collect data. So in terms of theory development, from a practical perspective, you can even use incomplete data, data that has a lot of holes in it, for coming up with some tentative ideas about what is actually going on in this situation, how these constructs might be related. So you're able to identify the what and the how, and come up with some, and it might be competing explanations. So you might have a few different whys, and then test them out with more reliable data. In the case of low integrity data in intermediate theory, that's the fourth cell in my conceptualization. I think the problem there is that in terms of intermediate theory, you have some theory. And testing it with invalid or unreliable data or incomplete data is somewhat problematic. Why? Because it won't really lead to new knowledge. You won't be able to come up with new propositions or new hypotheses because the data is not reliable. What you're saying doesn't contribute to more firm knowledge. Now, what can you do? Well, you have the logic, you have the theory. Can you use the theory to try to improve the data? So if the theory suggests something, can you go and find data that fits that? And then this would be sort of theory-driven search for data. And is there a problem in that? Yes, you will find data that will sort of conform to that theory. Now, once you have data that conforms to the theory, then obviously it's going to explain the theory. But you can, in the case of big data, you can always go and get new data, unseen observations. So once you build your data using this, and you have some ideas, you can always test them on a new set of data. And once it is tested against unseen data, that process of a sort of theory-driven data development is not so negative anymore. You can actually reduce the negative impact by testing it with new sets of data. So that's my conceptualization of how big data can be used for developing social science theory. Now the second part is machine learning, and machine learning being used for developing social science theory. What is machine learning? Machine learning is basically learning by algorithms using data representations. So we represent the data in a certain form, the algorithm learns from that data, and it becomes better on a predictive task. And it's different from causal modeling. So causal modeling in the social sciences has basically focused on effect sizes. So the idea is, does A affect B? And if it does, how much change in A leads to how much change in B, which is basically the regression coefficient in regressions. So that is the central thing that we have focused on in terms of building predictive models in the social sciences. However, in machine learning, predictive modeling is different. We are focused on the prediction. We are not focused on the beta. We are focused on the y hat. So we want to have a prediction that is as close as possible to what had been predicted. And this is this trade-off between bias and variance. Bias is where you have an accurate model. You're trying to predict exactly what is going on. Variance is that you're trying to explain things in terms of new samples. So you're trying to say, can this model explain unseen observations? And in machine learning, you give up a little bit of bias for reducing variance. You want predictive accuracy. In the social sciences, you want low bias models. You want a true explanation. So in that sense, machine learning is a different approach addressing a different problem. And social science theory development relies on low bias models. But machine learning allows for reducing bias of models as well. All machine learning algorithms have lots of tuning parameters. And these hyperparameters are actually focused upon reducing bias or reducing variance. So there's this trade-off. So you can actually use the same tools for developing truer models by now making a choice where you actually have lower bias models than choosing low variance models. So there's three main types of supervised, semi-supervised, and unsupervised learning. And I kind of point out, since I pointed out the attributes of theory, how each one of them actually contributes towards theory development. So in terms of what, let me sort of quickly point out what supervised, semi-supervised, and unsupervised learning are. So supervised learning is where you have a set of labels. So it's like you tell the algorithm, these are the correct choices, learn from these choices, and now predict unseen observations. So that's supervised learning. Semi-supervised is you have some labels, but not all of them. So you've told the algorithm, yes, these are examples of what happens, what leads to this. So say, for example, if you're trying to predict A from, say, B. So many cases you give A's which are related to B's, but in some cases you don't. And then you expect the algorithm to be able to learn from that and sort of fill in the blanks. In unsupervised, the algorithm is just given a bunch of data. Go ahead.
Omar, I just want to give you a quick time check.
Yes.
I think we're at 9:25 right now. So you probably want to tie it up here pretty soon. There's someone else I think is scheduled to start. You're scheduled to start? Yeah. Okay. Probably take a couple minutes, tie it up.
Okay.
And then let everyone know where they can go to get the rest of the information.
Okay, sure. Yeah. So basically what I've done here is that I've looked at these dimensions of theory, and then I pointed out how these dimensions can be used to develop the different types of learning, and how this can contribute towards theory development. And basically, just to sort of quickly summarize, in terms of supervised learning, you can select important variables, and that gives you the what part. The how part is you have multiple types of complex relationships that you can use to sort of show these relationships. In terms of why, you can test out multiple competing explanations. And then in terms of the boundary conditions, you can try out different moderators and mediators. In semi-supervised learning, there are algorithms which will complete the data set for you. And then from that point onwards, you can come back to the supervised learning and apply these type of things. In unsupervised learning, you can basically run the algorithms to come up with some tentative explanations for what groups, patterns are identified in the data. And then you can sort of take that to develop ideas, develop propositions, and come back. I have a paper that is under review on these topics, and I'm taking it in a way that I will develop an actual empirical application of these ideas. So if anybody's interested, get a card and send me an email, and I'll send you a copy of the paper. Thank you very much for your time.